All right, continuing on in this process, we have our texture region component, we have our animation component, we have them all set up. We're using our asset manager, we're creating an atlas, we're using the atlas. Now we need to start creating some systems. So let's go right click on systems, let's add a new system, and this is going to be our render system. This is going to extend the iterating system from Ashley. Let's go ahead and implement the methods, which is process. Now we need to think of what we need for a render system. We will have to have our sprite batch, because our sprite batch is what is going to draw all of our stuff, and we need to do it all together. So sprite batches, you don't want them to run and process an entity, draw it, and then run again. You want to get everything that needs to be drawn in the frame and then it to all be drawn at once. It's a lot less intensive. So we are going to finally start using our sprite batch, batch. Let's go ahead and import that. Why are you not like this? I need to add my constructor, but I'm going to add this first. Okay, so we have our sprite batch. We need to hold a list of all the stuff that has to be drawn. So I'm going to use an array that's going to hold the entities. And I'm just going to call it bodies Q. Q-U-E-U-E. And we need the camera, so we know how to draw it. Orthographic camera. We could probably use the viewport. I might change this later on, but for now we can just leave it. Okay, so we have an iterating system. Let's just go ahead and click OK. What do we need? We do need the sprite batch and we need the orthographic camera. What do you not like? Okay. I'm not passing in the family. We're pulling the family. So the family is family all. We need all renderable. Yeah, let's go ahead and do that. Renderable components. That way we can still create stuff that could have a texture region, and we could pull the renderable component off if they went invisible or something to that effect, if we still wanted the entity to exist and stuff to still happen. Okay, so the renderable component, though, is not really going to be anything except for it's not even going to hold anything. It's really going to act as a flag for our stuff. Let's just go ahead and add that. Renderable. So it is implementing the component and the poolable. We gotta implement the reset, which is not doing anything. Okay, so this component is literally not doing anything, but we still have to set it up for adding to let us know that it needs to render. Okay, so an entity manager, this should be pretty quick. Yeah, that's what I thought. Private entity add renderable component entity. I don't even want to add that. We just need to actually add the entity. Entity. Renderable component equals engine dot create component renderable component dot class. Okay. Entity dot add renderable component and return entity. That is it. All right, so they can draw, so I'm going to add the renderable component, and I just need to pass the entity. And say my enemy. I don't have anything set up for him right now, so I'm going to leave that one blank. For my coin, add renderable component entity. Okay. Now heading back to our render system. So the reason why I did this is because if I was setting up the system to run off of textures or animation, but I don't want the player to show up, it would be better for me to just use a flag and pull it off, and I can still hold all of those textures and animations without having to worry about anything. Would make it a lot easier. There are different ways that we can set up the renderable component. If I wanted to pass in colors and I wanted to change things, my render system could run in many different ways. The way that I have it running, though, I feel is it works for this game, and you guys can make changes to it. It's not difficult. So we have this method for this system, the process entity, because it's an iterating system. So it's going to check everything that has a renderable component. And so when we do the process entity, it's going to check that entity, and then it's just going to start processing. But since we want everything drawn together, we're not going to actually draw in the process entity. All we're going to do is we're going to add it to that bodies queue. So that body queue is going to have to be created in a constructor, and we're just going to pass in the entity. That's it. Our render system here, we need to actually create that bodies queue. So bodies queue equals new array, and we are done with that piece. All right, so we need another method though, and it's going to be the update method. So let's implement or override some methods. So we want to update based off of delta time this system. And what it's going to do is it's just going to process the batch. So the first thing that we need to do with our batch, and let me just double check. our main game screen. I need to see what that looks like, because there's some code that we can pull into our system itself. All right, yep. Okay, so in our render system, what we have in our main game screen, we got this right here where we are clearing, and then our map is drawing, and then it's rendering, and then we are updating. Eventually we're going to split this out for well, let's go ahead and we're going to leave that here for now, but we will probably end up moving that, especially if we ended up wanting to create a component for the map to render. But every time the engine is going to update, it's going to pass up the delta time. So in our render system, when the engine updates, it's holding onto that delta time, and it's going to call updates for all the systems. This update is going to take that delta time, and what we are going to do with it is, first we are going to have to take the batch, and there's a couple things that we got to do, and that's where the orthographic camera is coming in, because the batch, we have to basically calculate what should get drawn based off of the camera. So that's what's set right here, but we haven't used it. So we're going to do batch.set projection matrix, and this is the drawable area. So what we could see with the camera, which we're going to have to set as camera.combine. So it's going to process all of that information. And then we need to set a begin method for our batch. Everything between a begin and an end method will be what's going to get processed all at once. So it's going to take all of that stuff at the begin. It's going to take all of the stuff that needs to get drawn, put it all together, and then when we end up doing the batch.end, that's when it's going to end up doing it all. So we have a batch begin, we have a batch end, and then afterwards, that's when we would want to clear all the bodies that were added, which were the things that should be drawn. Okay, so here in between this, we're going to have to create a for loop that's going to pull every entity from the bodies queue. And what we need to do is we're going to use the texture components, texture component, texture equals mappers dot texture component dot get entity. Okay, so we're getting the texture component from the entity, and then we're gonna have to do some stuff with that, and we're also gonna have to get the position of the what did we put for transition? Transform component. Okay, so our transfer component is actually holding our position and all of our stuff right here. So this is where we can actually use, so we want our transform component, which I'm going to just call, let's just call it transform. Transform. Let's use mappers dot transform component dot get entity. All right, so we have those. I feel like I'm forgetting something. Okay, so now we can call the batch and we can say we want it to draw, and then we are looking for that texture. So that's where we go texture for that entity dot get region. And then we have a number of things that we can actually set. So here you have a region, you can put your X and Y, you can put your the width and the height, the origins, the width and height, the scale, the rotation, all of this stuff we can end up setting for how we are going to draw our entity. So right now our physics system, let's see that, which one of these should be updating our transforms. Okay, so here our physics system, even though it's processing our box 2D body stuff, and it's pulling that transform component, and the position of the body is getting stored as the transform component. The rotation of the body is getting stored as the transform component. Okay, so because that is running, we are going to use that information, the position that we get from the transform component, to set where we want to draw our stuff. Now, depending on your sizes, scaling, any of that stuff, this is where you're going to end up having to play around with to make sure that it's drawing it how you are intending it to draw. So there will have to be some tweaks, what I'm getting at here on drawing. We may end up having to consider that the box 2D position is not the same as the texture region position. Box 2D will store as the middle point of the element is the center, and let me just draw this out. No, I want the pen tool. Okay. Alright, so when we are looking, let's say that we have a square box. I am not very artistic. Okay, box 2D will say this is the middle position. Okay, for texture regions, it starts its point down here. So unless we have already dealt with that, then it is going to be off by half a width, and it's plus half a height, okay, from that position. So we will probably have to do some conversions, but we only have to do it here, and then it's going to correctly draw all of our stuff where we want it to be. Okay, so we first want to get that region, and then we're going to have to set the position. So transform dot get position. Now this is a vector 3, so dot x, and then I'm going to need my transform dot get position dot y, and the z that we are storing, that is so that we could choose to change if we wanted the player or anything to be drawn in front of or behind things. We could change the z, so we could have it order by stuff that has a lower z index to draw in the back of other stuff. We're not rushing to get that set up. But we got our X and Y of where we want it to draw. We need to get the width of our texture. So texture.getRegion dot get region width, texture dot get region height, and just okay. So we got our region, our X and Y. we got our width, and we got our height. And then if we needed our rotation, we can also pull that rotation. Now, for how BoxTD moves, we may not want to hold on to our region, especially our rotation, especially if we are locking it down, since Box2D could rotate, especially if we're using AI for having it try to intelligently go through areas. It will rotate, which would make our animation also rotate. If that is what you want, though, where you do want it to rotate for whatever way it's facing, you could do that. It kind of just depends on what your needs are. So I don't need the rotation. So to me, that is fine, where I just have the X and Y and the width and height and then the region. Okay, now I finish off with the batch.end and I clear the bodies. So that is set up, but I still have to now link up my render system in my game. So if I go into my main game screen where I'm initializing my stuff, so here's my systems. Let's go and we'll add another system in case we need to reference it. Private render system, and then in an Ashley system, we need render system equals new render system. We need the batch, and we need the camera. Okay, and then we have to add that. So I do need that to happen after the physics system, because the physics system is what is changing the my position. I also need this render system to actually happen after my animations, because my animations are going to update my textures. Okay, so it doesn't have to run an entire time before it switches. So let me just put a comment. Animation system needs to run here. Okay, and then we're going to add system, and we got the render system. Okay, so that should be linked up. As long, I don't remember if I created a coin or not in the tiled map. For the test map. So let's see where we're at. We air it out, null pointer, render system, update. So this might be because I don't have that item. Okay. Okay, so now we're actually trying to pull it. So when we are spawning the entities, let's go ahead and say what the entity is, so we can see what each entity is created in here. So I'm going to do a gdx.app.log, and because I'm creating this, let's change that loading screen because that's also annoying. The time to wait. Okay, so I'm loading my entity. Entity manager is running. String tag equals entity manager dot class dot get simple name. Okay. Now, when we are creating that entity, we want to know what we just created. Created plus entity name. Okay. Let's run it again. Alright, we created the player. It says we created an enemy and we created a coin. But it does recognize that we created the coin. Player creation, position 215, 231. All right. That's just right there. Let's find out where that was created at on our map. Coin creation. Our render system is missing some stuff, though. That's what's happening. This is freaking out. Coin 178 222. It's having an issue getting the position X and the position Y. Now, let's look, because I'm pretty sure we never even hooked that up. There is no transform component for the entities that we created. And if we look at our mappers, we have it. Type, state, texture, renderable. Type, collision state, body type, texture, renderable. We don't have anything to hold that position, so that is why it's erroring out. We need to actually create that or use it. Do I have it? Transform. I don't have the transform component, so I need to go ahead and build that to be able to have this run. So this is why we got to make sure that we are linking our stuff up and setting it. Okay, so let's go. Like our box 2Ds are doing stuff, but because we're not actually adding that transform, we're not able to pull that information. So we need to create another method, add transform component. We need the entity, we need the int x and the int y. Alright, so transform component equals engine dot create component transform component dot class. I just want to see who's calling that transform. Physics system is calling it. That's awesome. It's interesting that it didn't air out already. Okay, so let's set, so our transform component dot set position. We are setting, and we just have the X and Y. We're going to set X and Y, and that's what it wants. But we need a new vector. New, and I could probably have one of these inside my entity manager and put X and Y. Do I already have one? Because that'd be amazing. Yes, I do. Temp position vector. Let's use it. So, transform. What's going on? There it is. Okay. Temp position vector dot temp position vector dot set X and Y. Okay, and then we can just use that to set the position for our stuff. Then we need to add that to the entity. Entity dot add transform component and return entity. Okay, now our player needs to have that transform. Body type collision, player state, animation, texture, renderable. I want to put it right next to body. Add transform component, entity. I need that X and that Y. Okay. And I need to do that for everything. Body transform. Body transform. So right now my enemy doesn't have anything. Let's go ahead and run. There we go. And he is huge. Okay, so there are some things that we need to do to fix. This is setting my texture region. Now look, this is my box 2D body. That is sized correctly. This is sized to my world. My image, that is his bottom right leg. So it is massive. Okay, so we need to actually scale this down to have it draw correctly. So we have, up to now, we haven't had to use any scaling outside of having to scale from tiled to our map or to our game. For rendering, we're going to have to scale those texture regions down for our game. So we have to scale that down. So we could do that in the render system and then only have to do it once. So that is the X and Y. This region width, we need to divide by, and let me go to our figures. Okay, this is our virtual width, our virtual height, and our technical pixels per meter for our sizing. So here is where we have to actually scale down our image. I do not like that. Yeah, and we also got to do that for our height. Okay, now let's run it again. So our width and height will be in terms of our game size. Okay, so they are sized now correctly. But what I was saying is depending on where our regions are. So this position, how we have it set in our transform, is setting where it's the top, this bottom left is the position of our box 2D is in the middle. So we need our image actually to go over half the width and down half the width. So here our position, we need it to actually be, and let's make sure that we're referencing it, half of the width. So we need to subtract that X needs to go to the left, half the width, and then it needs to go down half the width or half the height. So I'm going to minus texture.getRegion width divided by 2, and same for this, texture.getRegion height divided by 2, and this also may need to be scaled correctly. Okay, so let's go ahead and run again, see where it is, because we want it to line up with our box 2D bodies. Here we go. Now we don't even see it at all, because that region is a massive region. So this actually needs to get divided by this whole thing. We are putting this in terms of this region width right here. We need to put that in terms of ppm divided by figures.ppm. Divided by figures.ppm. All right. Let's double check. Takes some tweaking. Yay! Okay, so now our image is drawn on our person. Let me scale this up so we can see that they are correctly drawn with our box 2D. When we move, our image is also moving, so that is what we want. and I collided with the coin. Okay, now notice that my image, or the box 2D, that is spinning around, but my image is staying the same. We don't have animation set up to change that texture region, but that is the next thing that we do. So when we're moving to the left, we need him to change states for left, and then to do the animation state for moving and for left. So that will be what we hit in the next video. All right, have fun, good luck.